Got a few rod sets that need new races. I got an engine in for rebuild. Guy had some S&S rods he wanted to use, but they were rusty. The race was rusty. I got the set off of Crusty, Musty and Rusty that's cracked. These are extra sets I keep laying around. They've all been lapped so many times that they're up to the plus 001 or 002 roller sizes. So I'm going to put standard races back in all these so we could start over again at standard rollers. When you're pressing out the races from the male rods, you don't want to drive them out, you know, just from the top, because you'll probably bend the rod. So I made a tool here that goes inside of the fork, and this ring that supports the rod, and you drive them out this direction so that the rod will be supported. So let's go do a couple. Alright, I got 5 sets of rods. The races have all been shoved out of them. I've kept the races with the rod sets. This is the set out of Crusty, Musty and Rusty. I got another engine sitting on the floor I'm going to start on. These are S&S rods that came out of that motor. 3 of these sets had cracked races and 2 were just worn out. So these races do crack and they do break. And on some of them, the cracks are very, very fine. They're hard to see. So you need to look at them carefully if you're working on rods. I've been measuring the rods in the races. The Harley manual doesn't talk about how to fit connecting rod bearing races. It says that if they get damaged or you can't get a good fit on them, to replace the rod set. So apparently Harley doesn't want you messing with these things. Since there's no instructions in the manual, there's no information on what kind of clearances you need to set up the interference fit between the race and the rod. So I took them all apart and I measured them. And the rods are not the same. They're pretty close, but they're off by 1,000th or so, one from each other. The S&S rod, the male end of it is 1.809, so that's the smallest of the bunch. And then one of the Harley rods, the biggest one, is 1.814. So you got a difference of 5 thou in manufacturing tolerances. The races vary. Let's see, 2,000ths. The races vary by 3,000ths. I'm not really surprised that there's that much difference. I mean, these rods, you know, were manufactured over the course of, 50 years or thereabouts. So, I would think it's probably pretty hard to hold a tolerance and have the first one off the assembly line in 1957 be the same as the last one off the assembly line in, I don't know, 1986 or whatever. So there is range. These replacement races I got, all of these that I have measured have been the same. And what I'm finding is that the removed clearances vary from a couple of thousandths of an inch over here to 0.08 of an inch tight on the SNS. I think I'm going to set these all up and I'm going to aim for 0.004. That looks like it's about average on all these. So how am I going to get there? I'm going to take these out to the lathe and I'm going to peel a little peel 0.05 of an inch off of them, because these things all make out to 1.822. So to get them down to a 0.04 interference fit, for example, on this first set of rods, I'm going to have to go down to 1.818 and let's see, 1.815. So I'm going to be peeling 4 to 7 thousandths of an inch off of the first set of races in order to get an interference fit for the first set of rods I'm going to try to do. I got the first bearing race set up on a mandrel in the 4-jaw chuck. I've been dicking with it to get it zeroed out on there. So as you can see, less than 1,000th of movement out of the needle. That should be good. So we're going to go ahead and get started and turn this one down. Okay, first race is in there. The target diameter is 1.818. Let's see if we can do it. We're just touching. Let's see. I need to take 5 off. All right, I'm going to try to do it all at once. Let's see what happens. Let's see how he did. Trying to get my hand in between the tool, the camera, and read the mic all at one time. Okay, the mic says I got another 1,000th to go. I think I'm there. Just a few 10,000ths over 1.818. I'm going to call that good. We're going to take it inside and try to install it. Alright, I'm going to press a race in the female rod. This thing's been baking in the oven and heated up to, expand the openings a little bit. And I drive them in the bottom first. Some guys that drive them in the top. I've seen another YouTube guy drive them in from the top. I don't do it that way because my concern is if the race gets a little bit hung up, this part of the rod being unsupported, you could easily bend the rod. So I made a little tool, my little tool here, install and remove tool, and that way I could, ouch. Okay, as long as I don't sneeze on it, it should be fine. I got it positioned where I want it, and I drive them in this way so that the rod is supported all the way around as the race is being driven in. It's going in nice. Perfect. Yeah, I got about a 5,000 interference on that. By the time the rod cools off, those two things ain't going anywhere. And there you have it. All right, here's all my rods. They've all been re-raced. It went fairly smoothly, tedious, time consuming, but went smoothly. I will say this, as an amateur machinist, one of the things I've learned is you can't skip steps and you can't take shortcuts. Every one of these races, when I put it on the mandrel, I checked the run out and adjusted it as needed. So that's 15 times I had a dial indicator on the race, making sure that it was running true. Every time the tool hiccuped, there's a little spark that shouldn't have been there or made a little funny noise, took the tool out, examined it, sharpened it as needed. This is the kind of thing you don't want to fuck up. And, saving a few minutes here and there saying, oh, I don't need to check the run out again. And theoretically, I shouldn't have had to. The mandrel was trued up with one of these races on it. The races are very precision. They're not going to go anywhere. Theoretically, I could have just popped one race off, popped the next on, and kept going. But, those are chances I didn't want to take on this job. Anyway, this is done. One other little thing did happen that was a little weird. Let me show you. Okay, this was a little unusual. I hit all these inner surfaces just with a little sandpaper just to, make sure there are no burrs on them or whatever. And on this rod, it was all galled up and through here. I think this must have been one of the ones that had a real tight fit. Some of these races were pressed in a lot tighter than the others. But anyway, pretty deep gouges and stuff in there. Some evidence of material transferring back and forth from a race to the rod. So as it so happens, I had an extra female rod laying around. So this is probably going in the junk pile, and I still have 5 full sets when all is said and done. Okay, I've spent the last several hours lapping these rod races to these bearings and this crank pin. So let's wrap this project up. I intentionally didn't show the lapping because it's just so filthy. I get covered with lapping compound. It's very hard to video that. So I didn't video it. I got a previous video on lapping. I don't remember which one it is, but it's back somewhere in my history. But let's wrap this project up and look at some numbers. We're going to measure the crank pin, we're going to measure the rollers, and we're going to measure the rods. and add up the numbers and see what the clearances ended up being on this. So let's see what this is. Okay, I come up with 1.250 and 2. This doesn't read in 10,000s, but it's over 250 a little. Okay, I do have a 10,000ths reading 0 to 1 inch micrometer. Turns out I don't need it. I got one of the connecting rod rollers in there, and it comes out to 0.1870 exactly. So that's the diameter of a standard roller. Let's measure the diameter, finished diameter of a lapped male race and see what we got. All right, let's measure that inside diameter and see what we have. Okay, pretty much 1.625 exactly. Okay, you take the diameter, the measured diameter of the lap race, the inside diameter, you subtract from that the total of the stacked up parts, the pin and the two rollers. You subtract one from the other and you get 0.0008. The recommended clearance in the Harley manual is 1/1000th of an inch to 1/2,000th of an inch. So we're right in the ballpark, we're right in the middle. So I could not have gotten a better result than this. This is good. Okay, my 5 rod sets are done. I'm very happy with the results. I had intended to show you how I do the bushings, but as it turns out, when I test fit the piston pins for the pistons I'm going to be using, they actually didn't go into the holes. So I used a dingle ball hone on these and I lapped them out. So the rods are all done. Very happy with it. I had intended to put the flywheels together, of course, but being a dumbass, I forgot to order a pinion shaft and a sprocket shaft, which it needs. So I had to put that aside. In order to keep from wasting the day, I assembled the transmission. And the transmission had a rusty main shaft and 4 rusty gears in it. So I put it back together again. And when I was trying to shift it, it shifted, but it didn't feel good. It didn't feel right. So I got to looking at it a little more closely. And of course, here is the shifter pawl mechanism. And what I found was that the pawls, let's say they don't even move, the pawls were rubbing on each other pretty significantly. And I thought, what the hell is up with that? I was going to say, what the fuck is up with that? But I toned it down, you know. Anyway, what the fuck was up with that? So I got to looking at it, and they're rubbing, severely rubbing on each other. So I, really hadn't paid any attention to this. But I took a closer look at it, and look at this shit. Look at this shit. The pins had broken out, apparently, and somebody welded them. And they didn't even weld them good. They ground the welds down, and they didn't even grind them smooth and flat. The pin that goes between the 2 springs had been broken off, and it just looks like a chunk of scrap steel somebody cobbled together and welded in there. Well, they got all this shit crooked or a little bent or warped or something, but the shifter pawls just don't work right. And I'm sure that was the problem of the bad shifting. Anyway, I had another trans. Took the pawls out of the other trans, put it in this trans. Everything works good. I am out of here. Hey, thank you all very much for watching. I really appreciate it. The best thing y'all could do to support me is hit the subscribe button. But no harm getting yourself a coffee cup, getting yourself a sticker, or joining me on Patreon. Thank you. We'll see you next time. Bye.